Okay, so our galaxy, the Milky Way galaxy, it's about 100,000 light years across. So if you were traveling at the speed of light, it would take 100,000 years to get across. A light year is a huge number, or a huge distance. It's 5 trillion miles, on the order of 5 trillion miles. We look at the galactic core there. That is where the most of star formation is. That's the most radioactive area. Our solar system is actually about 27,000 light years from the galactic core. So our sun orbits around the Milky Way galaxy. Milky Way galaxy is only about 1,000 light years in depth or in thickness, but yet 100,000 across. Here we see an animation of our sun, our solar system, really moving through the galaxy. It takes 226 million years to make a galactic orbit for our sun. Our sun is producing a stellar wind. It's actually running into things and just ionizing them and creating almost like a force field that's protecting the planets as they trail behind. There's somewhere between 100 and 400 billion other stars in the galaxy. It's difficult to know how many stars exactly because, we're just on this planet going around a star. There's a lot that we can't see. Uh, some of the oldest stars are actually as old as the universe itself. And up until the 1920s, we actually thought that the Milky Way was all there was. All the stars you can see in the sky, all the stars you've ever seen with your eyes, are in the Milky Way galaxy. So, yeah, up until the 1920s, we thought that was all there was, but now we know that there are other galaxies out there, although very, very far away. 226 million years to make the galactic orbit for our sun. So, since before the time of the dinosaurs, our sun has been in this same orbit. So here are the planets, just kind of relative size, definitely not distant. These planets are way, way out there. Neptune is so far away from the other planets, and so on. So Mercury, Venus, Earth, Mars are the inner planets. Jupiter is the first of the outer planets. Jupiter, the largest. Saturn, Uranus, and Neptune. So Jupiter and Saturn are the gas giant planets. Uranus and Neptune are the ice giants. And again, Mercury, Venus, Earth, and Mars are terrestrial planets. They actually have surfaces that you could stand foot on. What we don't see between Mars and Jupiter is the asteroid belt. So there is actually an asteroid belt, Mars, which is the fourth planet, and Jupiter, which is the fifth planet. So that's kind of like the dividing line between the inner and outer solar system. The sun is the largest object in our solar system. It's 99.8% of the mass of the solar system. So everything else combined in the solar system, 0.2%. Even massive Jupiter doesn't even account for 0.2% of the mass of the sun. Surface temperature about 10,000 degrees. And actually, it's hotter in the coronosphere further out. We have a probe, the Parker Solar Probe, is diving through the coronosphere right now and withstanding huge temperatures, 27 million degree core temperature. I did mention that the sun is one of somewhere between 1 and 400 billion stars in the Milky Way. We don't actually know how many there are because there's just a lot of dust. There's a lot of debris in our way that we can't see. We're looking back at the galactic core here as you see the Milky Way. That's why it was named, is for this cluster effect that you see here from Earth. But there is a bunch of debris in our way, a bunch of dust from nebulas such as this Carina Nebula, which is it's kind of like a stellar nursery. So it's where stars are born. All this dust coalesces, and as gravity increases, it gets hotter and hotter and hotter, and it actually spins and turns into a protostar and eventually a star. Mercury is actually the closest planet to the sun. It's actually tidally locked to the sun, which is to say that one surface always faces the sun. We're actually looking at the cold side of Mercury, which is very, very cold, colder than temperatures here on Earth. And then the other side of Mercury is actually super hot because it's always facing the sun. The length of its year is 88 Earth days, so it's going a lot faster. It takes 365 days for the Earth to transit the sun, to orbit the sun, and just 88 for Mercury. Here you can see an image of Mercury and the moon. And once planet, now called a dwarf planet, but still very interesting little guy. It's got a giant moon, does Pluto, called Charon, which is almost as big as it is. And then there's Venus. Venus is actually the hottest planet. Its surface temperature 900 degrees Fahrenheit. It is so hot because there is just a huge cloud of carbon dioxide as a main component, 90 times more dense than our own atmosphere. So just crushing pressure and extreme heat. So yeah, Venus's day is 243 Earth days, but it actually transits the sun much, much faster. So it only takes 225 days for Venus to go around the sun. So for Venetian years, 225 days, 243 days, Earth days, for Venus to actually turn. Like our day is 24 hours. It's 243 days to rotate around. Here's Earth and Venus. Now, Earth is bigger than Venus. Venus is about 90% the size of Earth. The Earth is 81 times more massive than the Sun. It's the largest of the rocky planets. And yeah, it's time to switch to game time. So we're going to go to questions. We'll come back. Well, we're going to go exploring solarsystem.nasa.gov next after the game. So we're going to play a game and then we're going to explore the solar system. So Danny, you've got the first question. So Danny, go ahead. Pick a category. Oh, by the way, all the stars we see, that's our galaxy. And I think everything else is pretty self-explanatory. Some of the stuff we haven't really talked about, but we're going to come back to this. You can kind of maybe investigate, and we can, that'll help you know what to listen into as we go through. So all the stars we see for 100, yeah. This is the galaxy, the name of the galaxy we live in. Exactly. Yes. The Milky Way galaxy. Yep. And you can see the dimensions here. It's only 1,000 thick and almost 100,000 light years across. So, yep, you get 100 points there and you get to keep the floor. Planets for 100. Okay. This is the closest planet to the sun. Closest planet to the sun. Did you catch it? About 10 seconds. Think about it. Do you know the answer? Okay, it seems like Nathan wants to answer. Nathan, do you have the steal? Do you know the answer, Nathan? Yes, it is Mercury. So Nathan gets the steal, and he also gets to take the floor. So Nathan, your choice. Moons for 100. Okay, we haven't gone over this, but yeah, maybe you know it. This is the object that has the most influence on the tides of Earth. Yes, yep, it is our moon, of course. Yep, very good. And you retain the floor. By the way, if anybody gets to be 500 points ahead of second place, then we're going to switch to the next person in line. But Nathan still has the floor. You want to do all the stars we see for 600. Okay, all right. But this is the approximate amount of time it takes the sun to orbit the Milky Way galaxy. So how long does it take the sun to orbit the Milky Way galaxy for 600 points? So this is a tough question. Did you catch that? No? Okay. Does anybody have a steal on that one? That's a tough one. Okay. We'll go ahead and go to Loretta. It's your turn. You want all the stars we see for 200? These are the dimensions of the Milky Way. So any dimension that you can remember of the Milky Way. What did you catch? Yes, that is correct. Yes, 100,000 across. That does work. So 100,000 light years across, and it's 2.2 million light years to the nearest galaxy. So at the speed of light, it would take 2.2 million years. That's mind-boggling. But nicely done, Loretta. Okay. Moving on, your choice once again. The planets for 200. Okay. This is the most distant rocky planet from the sun, as recognized by NASA. There's some dispute as to what the most distant rocky planet is, but yeah, we're going to go with what NASA says. Did you catch what the most distant rocky planet is? Got about 10 seconds to think about it. Most distant rocky planet? Any idea? No idea? Okay, I think Hao Chen has the steal. Hao Chen, what was it? It is Mars. It is Mars. Correct. Nicely done. And you have the floor. You can go ahead and take over. Go ahead and pick a category. Deep space probes for 300. I mean, we haven't talked about that. Something we're going to cover, but okay, we'll take a look. Oh, this probe dives through the hottest parts of the sun, and it is also the fastest spacecraft created by humans. Anybody catch that one? Or I guess we're with Hao Chen, right? Do you know the answer to that one? Nobody caught that. Okay, well, yeah. It's the Parker Solar Probe, the Parker Solar Probe. And we'll take a closer look at that here in just a moment. We're going to dive in and look at the planets from another perspective here after the game. So let's go back. I believe it is Nathan's turn now. So Nathan, go ahead. All the stars we see for 300. Okay. This is the approximate number of stars in the Milky Way galaxy. This is the approximate number of stars in the Milky Way galaxy. Yes, it is somewhere between 100,000 and or 100 billion and 400 billion stars. That is correct. Yes. And so Nathan, you get another 300. Do keep an eye on me. If I forget to give you your points, make sure you let me know. You got to holler at me and make sure you get your points. Okay, so you got 500 points. So you're not 500 points ahead of anybody yet. So you get to go again. You want to do the planets for 300. This is the name of the third planet from the sun. Did you catch that one? And yes, you're correct. It is Earth. It's the one we live on. Nicely done. So now it needs to go to Danny because you have more than 500 points more than Danny. So Danny, it is now your turn to go. Go ahead and pick a category. Okay, so our solar system, outer solar system for 100. This is the largest planet in our solar system. It is Jupiter. Very good. Danny, you have the floor once again. Go ahead and pick a category. Outer solar system for 200. Okay. All the outer planets have rings, but this world has highly reflective ice rings, making them visible from Earth with the most basic of telescopes or binoculars. And this is the last question. We're out of time on this. What is the name of that planet? Any idea? The planet with the rings that you can see from Earth. Which planet is that? About 5 seconds. Okay. Hao Chen wants to steal. Hao Chen, do you know it? It is Saturn. Nicely done. Okay, we're going to get out of the game here and we're going to go explore the solar system together, courtesy of NASA. So solarsystem.nasa.gov. You can check this out at home. Again, solarsystem.nasa.gov. We just clicked on the little solar system icon and you can actually zoom in here. So as we move in, you can actually see the different space probes. So Voyager 1 and 2 were sent out in the early 70s or mid 70s. You can see some comets. Pioneer, another probe. New Horizons took the fantastic photos of Pluto. And as you come into the inner system, you notice you have Neptune way out here, and then Uranus. There we can see Saturn as we come in. Jupiter, the largest planet in the solar system. There's Mars, the fourth planet. And there is Earth there. And of course, Earth and our moon would be right there. But let's jump to Mars. So you can take a look at Mars here. So Mars actually does have two moons, Phobos and Deimos. You can see this iconic crater valley. I think it's like about 7 miles deep is that gash on the surface. We can actually, so you can actually compare sizes of, here is Mars versus the Earth. So we're looking at maybe terraforming Mars one day. It would be a much smaller planet. The gravity is about a third of that of the Earth. But again, yeah, Mars is the most distant of the rocky planets. Set a timer for 6 minutes.
6 minutes, counting down.
And let's zoom out here and take a look at Jupiter next. So we're kind of focused so you can see Deimos and Phobos. So again, these are the moons of Mars. They're very small moons, they're more like captured asteroids. But let's zoom back out and find Jupiter. So the largest planet, where is Jupiter? Need to go out further to intercept it. Here it is. Here's Jupiter. And yeah, Jupiter, the largest planet, has 79 moons. The largest moon in the solar system is actually that of Jupiter. Let's zoom in and maybe we can see these moons. There's 4. There's 4 Galilean moons. There's Io there. Io is the only volcanic moon that we know of. So it actually has active volcanoes. I'm not sure. What are we seeing there? Oh, just shadow. But we have Io. Ganymede is actually the largest moon. There's Europa, which actually has an atmosphere. It's got a lot of liquid water probably under the surface. Callisto, another one of the Galilean moons. But yeah, Ganymede is the largest moon in our solar system. And yeah, let's take a look at Ganymede versus our moon. So Ganymede, much, much larger than our moon. Again, the largest moon in the solar system. Jupiter is a giant planet, so it makes sense that it would have a giant moon. Earth's moon is actually pretty substantial in comparison to the size of the planet itself. Ganymede is not very, very big compared to Jupiter itself. Anyway, so Ganymede much smaller than Jupiter, its parent planet. And actually, we could kind of zoom out here and maybe get the two in. Yeah, you can kind of see how tiny it is. And let's go out to Saturn. So Saturn again has those rings. You can actually see them. Once you know where they are, you can kind of see them with your own eyes. And there is Saturn. Saturn also has dozens and dozens of moons. I forgot to mention the astronomical unit. So the astronomical unit is the distance between the sun and the Earth. That's 1 AU, 1 astronomical unit. Saturn is 9.5 astronomical units apart. Jupiter, let's go back to Jupiter real quick, is only 5.2. So it's almost twice as far out. We're talking billions of miles. Now Saturn is like 1 billion miles out from the sun. 9.5 astronomical units. The great moon Titan is one of the moons of Saturn. Saturn again has many, many moons. It's way out there as far as almost 10 astronomical units from the sun. It's a long way to get there. But then the next planet, which is actually Uranus, which is way over here, the 7th planet, now we see is 19.8 astronomical units out. So it's almost twice as far again. So it's twice as far out from the sun as is Saturn. And so 27 moons. This is one of the planets that we've never orbited before. So we've never had a spacecraft actually orbit Uranus or Neptune. So the most distant planet is Neptune here. And we've never had anything orbit Neptune, none of our spacecraft. And the 4 outer planets all do have rings. So Jupiter, Saturn, Uranus, and Neptune all do have rings, but they're just difficult to see from Earth. We don't see them because they're not shiny, they're just rock and dust and whatnot. So, but 30 astronomical units out, so 30 times the distance from the sun as Earth. Earth is 1 astronomical unit. Yeah, Neptune is out there 30 units. So, yeah. All right, let's go back to game time now. So, we're going to go back to our Jeopardy game. Set a timer for 7 minutes. All right, so who left off? Let's just say, yeah. Was Loretta? Okay, so Loretta, go ahead and choose your category. The planets for 400, okay? This is the planet with the highest surface temperature. So the planet that has the highest surface temperature in the solar system. It is Venus. Yeah, Venus has that thick atmosphere that traps the heat in. Second planet of the sun. Kind of strange that it's further away than Mercury, but Mercury doesn't have an atmosphere that's holding in all that heat. So that makes sense. And okay, so all the stars we see for 400. Okay, this is the name of the stellar body that the planets follow as it orbits the Milky Way galaxy. What is the name of the stellar body that the planets follow as it orbits the Milky Way galaxy? It is the sun. It is the sun. And now, Loretta, you are more than 500 points ahead. Danny went last, so we're going to go with Hao Chen this time. So, Hao Chen, wait, there's no picture? Okay. Okay. Our outer solar system for 300. These are the gas giant planets. Correct. Yes, it is Saturn and Jupiter. Very good. Very good. Okay, you have the floor once again. Go ahead and choose. Oh, wait. So you're 500 ahead. Ah. That's yeah, go ahead and choose again. Go ahead, Hao Chen. Our outer solar system for 400. Okay. This is a number of astronomical units between the sun and Neptune. An astronomical unit is equal to the distance between the Earth and the sun. So we just actually saw this. We just talked about it. Do you know? So how many astronomical units? You don't know? Okay, it sounds like Nathan has the steal. How many, whoops. How many astronomical units, Nathan? No, it is not. It is not 9. Danny, you know? It is 30, Danny. Nicely done. All right. Congratulations. Okay, so you have the floor now, Danny. Perfect. You want to choose a category? Moons for 200. This is the number of moons around Venus. How many moons does Venus have? How many moons are around Venus? That is incorrect. Does anybody have the steal? Hao Chen, go ahead. There are no moons. Correct. There are no moons around Venus. So you get the steal and you get to keep the floor. Go ahead. Moons for 300. Okay. This is the number of moons around the 4th planet. It is 2 moons. Yes. Phobos and Deimos. Very good. And yeah, they're tiny moons. Really, this is not to scale or anything. Phobos is like less than 10 miles across ish, somewhere around that. And Deimos is only like a mile across or something like that. They're tiny. They're just asteroids, basically. But very good, Hao Chen. So that's actually okay. You can have one more question here. Go ahead, Hao Chen. You have the lead here. All the stars we see for 600. Okay. This is the approximate amount of time it takes the sun to orbit the Milky Way galaxy. So, how long does it take for the sun to orbit the Milky Way? And you got about 5 seconds on this because it's going to tell us. I need to stop this. You don't know. Okay. Does anybody know this one? It's actually 226 million years. So before the time of the dinosaurs, basically, the sun was in this current orbit around the galaxy, around the galactic plane. They say 220 million, 226 million years to go around. Okay. And so let's go back. So Nathan, you are up. Your category. Go ahead. All the stars we see for 500. Okay. This is approximate distance to Andromeda, the nearest galaxy outside the Milky Way. Did you catch that? Give you about 10 more seconds. What is the distance to the nearest galaxy outside the Milky Way? So Andromeda galaxy, how far is it? A couple million? Yeah, you know what? I'll give you credit for that. That works. Yes, it is a couple million. Yeah, it's like 2.2 million or something like that. 2 million light year. 2.2 million light years. So if you could travel somehow at the speed of light, it would still take 2.2 million years. Pretty crazy. Okay. And yeah, so let's go to Danny now. So, Danny, it is your turn. Go ahead and choose. Planets for 500. Okay. This is the group of objects considered dividing line between the inner and outer solar system. So, what is the dividing line between the inner and outer solar system? And this is the last question, by the way. We're out of time for that. It is the asteroid belt. It is the asteroid belt. Very good, Danny. Awesome job, everybody. Well, yeah, that's all we have time for today. Thank you all for joining me. I hope you enjoyed it. Yeah, I look forward to seeing you all again sometime soon. Okay, take care. Bye bye.